All right, college algebra, we're in rational functions today, section 3.4a. All right, this is a rational function right here. Rational has a root word, which is ratio, and ratio is when you compare two numbers by division. All right, well, the rational functions, when we're doing division here, and we have an expression divided by an expression. Okay? Now, it's intriguing what these graphs look like when you graph this thing, because what happens is you have what's called asymptotes. You have asymptotes. You have vertical asymptotes, and you have horizontal. Okay? Vertical asymptotes are real simple, and we've actually discussed vertical asymptotes in a sense, but haven't really mentioned it. But right here in the bottom, in the denominator where you have x minus 3, we know from our domain that we cannot have 3. X cannot be 3, because if I have 3 for x, 3 minus 3 would be 0, and I'm dividing by 0, and that's not possible. So this value here we can't have. Well, that's my vertical asymptote. The vertical asymptote is whatever has a 0 in the denominator. Plain and simple. Right here, x equals 3 is my vertical asymptote. That's a value we can't have. And so what happens when you graph this thing, let's put a little sketch here. And at 3, here's 3 right here, we have a vertical asymptote right here. And that's a value x can't be. And so what happens is this graph, it'll be coming through here like this, and all of a sudden it just curves down and it hugs this asymptote, and it just gets closer and closer and closer to it, but it will not ever touch it. Then on this side of it, it'll do something like this. And so right here at that value, it can't be 3, and so it never touches this asymptote. The graph does not ever touch it. You could pick values that's real close to 3, and you can see what happens with this division. Like if I did like 3.1, like here's 4, or here's 3.1, real close to 3. So if I do 3.1 plus 2, I get 5.1. I'm just going to write it up here, 5.1. If I do 3.1 minus 3, I get 0.1. And if I divide this, I get 51. And so at 3.1, it's way up here at 51. And see, that's what happens. Now, so that's real simple on vertical asymptotes. Horizontal asymptotes are a little bit, more involved in finding them. And I don't know if you can tell in this graph, but we have a horizontal asymptote right here, and it's 0. It's the x-axis. So it's my horizontal asymptote on this one is y equals 0. This is my horizontal asymptote. I'm going to show you how you find that. But in this right here, there's no way that this value right here will ever equal 0. There's no way. All right, so in finding horizontal asymptotes, there's 3 cases involved. Okay, now you focus on, it's supposed to be on, not of. Focus on degrees of the numerator versus the denominator. Okay? So in case 1, if the denominator degree is greater than the numerator degree, okay? If the denominator degree is greater than the numerator degree, okay, then that means y equals 0 is my horizontal asymptote. Okay? Number 2, if my denominator degree is equal to my numerator degree. Okay, then on this one, we divide the lead terms. Okay, and then that tells us y will equal whatever that comes out to be, which is what we would have done here. And so on this one, I don't think it really could be 0. I think on this one it would be 1. But I graphed it to make it look like it was 0 when I was just sketching it. So really, technically, that was not right. And on 3 here, all right, we got the denominator is greater than the numerator, the denominator is equal to the numerator, and then we have the denominator is less than the numerator. Okay, that means we have no horizontal asymptote at all. And then on this case, we have what's called an oblique. Which is a diagonal asymptote. Okay, so finding the vertical asymptote is simple. Just whatever makes you have 0 in the denominator, bam, that's your vertical asymptote. But on your horizontal asymptote, you got these different cases involved. And you look at the degrees of the numerator versus the denominator. And if the denominator degree is bigger, it's y equals 0. If the denominator degree is equal to the numerator, then you divide the lead terms. But if the numerator is greater, or if the denominator is less than the numerator, there's not a horizontal asymptote at all. Okay, so that's what we're going to deal with in this chapter, and then we're going to graph some and all that stuff. So if you look at the first one here, number 1, match the rational function with appropriate description. So we have this rational function here. Okay, choose the correct attribute of this rational function. The vertical asymptote is x equals -2. All right, the vertical asymptote is the 0 in the denominator. And then my denominator, yeah, -2 plus 2 would be 0. So this is right here, A. Okay, that's my answer. Let's look at this one. This says the vertical asymptote is 5. Well, no, 5 plus 2 would be 7. 5's okay. It's -2x can't be, which gives us our vertical asymptote. And this is talking about the x-intercept and y-intercept. That's just, that's pointless there. These are. But the vertical asymptote is x equals -2. All right, look at the next one here. Pick the correct thing for this one. Okay, well, let's just look at it here. Actually, let's go back to this one real quick. What was my horizontal? Okay, if you look at this one, the degree in the numerator is 1, and the degree down here is 1. All right, so that means they're equal. Okay, so if you look at our notes we just did a minute ago, these are equal, so that means you divide the lead terms. So divide this right here, so this is 1 divided by 1. So 1 divided by 1 is 1. Y equals 1 would be my horizontal asymptote. Okay. So number 2 here, which are these? There's a bunch of these to look at. So what I'm going to do on this, I'm just going to figure out my vertical asymptote, and I'm going to figure out what my horizontal asymptote is, and then maybe I can figure out what answer it is. Okay? So if I look at my vertical asymptote, that's simply what makes me have 0 in the bottom here, which is -4. X equals -4 is my vertical asymptote. Okay? Now, my horizontal asymptote, we've got to look at the degrees. The degree in the top, look, this is just 3, and this is x to the 0. So the degree in the top, the degree in the numerator is 0. The degree in the denominator, well, that's x to the 1 power. All right, so if you look, the denominator is bigger than the numerator. So look at this. My denominator was bigger than the numerator, so it's y equals 0. So y equals 0 is my horizontal aspect, which is my x-axis. Okay, Now look and see if I have one of these two on here as far as these 2, 4, 6, 8 answers, 8 possible answers. Okay. Right here, the x-axis is the horizontal asymptote and the y-axis is the vertical asymptote. No. Vertical asymptote is -3. Nope. X-axis is horizontal and the y-axis is, all right, here it is right here, E. The x-axis is the horizontal asymptote and the y-axis is not, because it's actually -4, x equals -4. If this was x equals 0, that would be the y-axis. But the answer is E for that one. Okay, we'll go on here. Number 3. All right, this says identify the vertical asymptote. We got this rational function here. Identify the vertical asymptote. So, yep, right here. 4. 4 minus 4 give us 0. So there is one vertical asymptote. Sometimes you might have 2 or 3. But this is x equals 4. That's the equation of the vertical asymptote. Okay, down here, identify the horizontal or oblique asymptotes. Okay, well, let's look at the degree in the numerator. Okay, in the numerator, this is x to the 0 power, so that's 0. In the denominator, this is x to the 1. Okay, so you just find your degree in the numerator, find the degree in the denominator, and then you got to remember this right here. And on this one, my denominator is bigger than the numerator. See that? My denominator is 1, my numerator is 0. So y equals 0 is. So this has a horizontal asymptote, y equals 0. Okay, and I think we got this right. Okay. All right. Number 4. All right. Identify vertical, horizontal, or oblique asymptotes. Okay. Now, look here on these notes here, just to be a little more specific here. This is how you find your horizontal asymptote. If the denominator degree is smaller than the numerator degree, you have no horizontal asymptote, which means you have an oblique. You can't have an horizontal and an oblique at the same time. You only have an oblique if it's this third case. If it's these two, you have horizontal. If it's this one, you have oblique. All right? So now on this, number 4, here's my function. Okay, this is wanting the vertical asymptotes right here. All right, do we have one or do we not have one? Okay, well, we do have one right here. When does this equal 0? So look here, 2x plus 3 is my factor. Remember now, my 0 is going to be -3 divided by 2. This is my 0, which is x equals -3 over 2. That's my vertical asymptote. Okay. All right. What about the horizontal asymptote? All right, look at my degree in the top. Look, this is x to the 1. So my horizontal is 1. I'm sorry, my numerator is 1. My denominator degree, well, that's 1. And look, they're equal. Okay. On this one, the denominator is equal to the numerator. So I divide those lead terms. So I divide these. So this lead term is -6. See, -6x. And this lead term is 2. So I'm going to do -6 divided by 2, which is -3. There's my horizontal asymptote, -3. Okay. Now, right here, this next one. What's the oblique asymptote? Well, we don't have one. This is B. We don't have one because we have a horizontal. We can't have both. So since I have a horizontal, I don't have one of those. Okay. And so look here, man, we were right. -3 over 2, -3, and no oblique asymptote. Okay. Here's another one. Here's my rational function. All right, what's my vertical asymptote? right there, negative 4. Negative 4 plus 4 is 0, so negative 4 is my vertical asymptote. Okay? What about my horizontal asymptote? Okay, the horizontal asymptote. All right, the degree in the top. All right, in the numerator degree is 2. See, it's x squared. My degree in the denominator, it's x to the 1. So the numerator is bigger, which is this right here. We do not have a horizontal asymptote. We have an oblique asymptote. Okay? So on this one, there's not a horizontal. Okay? Now, so we have an oblique. Now, what is my oblique? All right, to find the oblique, figure out what the oblique asymptote is, you divide this. So we just do synthetic division. I'll just do that right here. I've got 1x squared, I have 0x, and I have negative 7. That's in my numerator. In the denominator, I do the 0 of this, which is negative 4. Okay? 1 comes down, negative 4 times 1 is negative 4. Add those, negative 4. Negative 4 times negative 4 is 16. Add those, 9. This is my remainder. But right here is my answer. This is 1x minus 4. And that's my oblique asymptote. Which means if I graph this, which we're not going to have to graph these obliques, but x minus 4, this crosses at negative 4. And then that's 1x, which is up 1 over 1. This is going to have an oblique asymptote, which just goes diagonally like this. It has a vertical asymptote at negative 4. And so what this will do, it will make a graph that looks like this, is what it will do. But anyway, that's just for your benefit. We're not really going to do any of those. Okay, look at 6 here. All right, here's my rational function. All right, what's my vertical asymptote? All right, look at the bottom here. This is a quadratic function, quadratic equation, or expression. So we need to figure out what our zeros are, so we're going to do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so my a is 2. 2 goes here and here. My b is negative 1. And my c is negative 10. All right, so that gives me a 1, a 4 down here, and in there I'm going to have 1 plus 80, 81. The square root of 81 is 9. So I got 1 plus 9, which is 10 over 4, which is 5 over 2. And I have 1 minus 9, which is negative 8 over 4, which is negative 2. So there you go. There's my zeros for this expression here, which means those are my vertical asymptotes. So I have 2 of them. So use a comma to separate those. So I have 5 halves and negative 2. Okay, I think you see the answer down here. That's my vertical asymptotes. Now, my horizontal asymptotes. Now, it's only an asymptote. You're only going to have one horizontal. Okay, what is it? All right, so you look at your degree. My degree in the numerator is 2. My degree in the denominator, it's 2. They're equal. All right, so go back to these notes here. When they're equal, you divide those lead terms. So we look at the lead terms to figure out what the degrees are. See, these are lead terms. They're the highest ones. So now I divide those. This is 1, and that's 2. So I do 1 divided by 2, which is just 1/2. So the horizontal is 1/2. And you can see that answer right here. See that? And then the third one, what's the oblique asymptote? Well, we've got a horizontal, so we can't have one of those. You can't have both. So since we have a horizontal, we do not have an oblique. Okay, here's another one, 7. Here's my rational function, okay. What's my vertical asymptotes for this? All right, so we got x squared plus 4. Okay, it's quadratic, so let's do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, look here, my a is 1, so I got a 1 here, 1 there. My b, oh, I don't have a b, so that's 0. And my c is 4. Okay, so this is going to be negative 0, which is 0, plus or minus the square root over 2. This is going to be negative 16. Oh, look, imaginary. So this is b. We don't have vertical asymptote. And really, if you look at this, there's no way this denominator can be 0. See, if whatever x is if x is negative, a negative number squared would make us positive. So I got a positive number plus 4. It's not ever going to get down to 0. If x is 0, 0 squared would be 0, and 0 plus 4 would be 4. So there's no way on earth this bottom could be 0, so there's no vertical asymptote. Okay? What about your horizontal asymptote? Well, my degree in the numerator is 2. My degree in the denominator, it's 2. All right, so you get your notes here. These are equal, which means you divide those lead terms. So I got to divide 5 divided by, that's a 1. 5 divided by 1 is 5. This is y equals 5. Okay. The answer is down here. You see, no vertical. Y equals 5 is horizontal. What about oblique? What's my oblique asymptote? Well, I got a vertical. I'm sorry. I've got a horizontal. So it means I don't have an oblique. Let me circle that right there. So I have a horizontal x equal, or y equals 5, which means I do not have an oblique. I can't have both. All right. Now here's some graphs. This says identify the vertical, horizontal, or oblique asymptotes in the graph. Okay. So first here, A, B, or C. There's a vertical asymptote. Its equation is there are 2 vertical asymptotes. The equations are, and then there's no vertical asymptotes. Well, if I look at the graph, I can clearly see there's one vertical asymptote right there. So this is A, okay? There is one vertical asymptote. What is it? It's right here at 1, 2, 3. X equals 3. Okay. Now down here in the second part, I don't know if I can pull that up any to get all 3 answers on there. Okay. So it says it has a horizontal asymptote, it has an oblique asymptote, it has no horizontal asymptote. Okay, well, you can see on here there's a horizontal asymptote clearly right there. So this is A. All right. Now, what is that horizontal asymptote? Well, it looks like it's 1, 2, 3, 4, right here at 5. Y equals 5. Okay. Now, it says right here, what's the domain of this function? What is the domain of this function? Okay. I'm just going to keep it up here, and I'm just going to write it right here, my domain. Okay. My domain, look, it goes to the left forever. It goes to the right forever, but there's this one value we can't have. See, it goes to the left forever, and it comes and it goes to this value, and it hugs that asymptote and never does cross it. And then it gets on this side of that asymptote and never touches it. So my domain, negative infinity, all the way up to this value of 3. Union, I put a parenthesis here because it will never equal 3. And then I do 3 to infinity here. And that's my domain. Okay, so 3, this vertical asymptote is a value I will not have. So this is how you take that value out right there. So my domain actually goes from negative infinity to positive infinity, but this value 3 I don't have, and that's how you take it out. All right, number 9. All right, check out this one. That's cool looking at it. As you can see, it's got 2 vertical asymptotes. You see that? So we're going to be here. There's 2 vertical asymptotes. The leftmost one is x equals, right here, the left one, that's negative, is it negative 4? Yeah, it looks like negative 4. And then the rightmost one is positive 4 right here. Okay? And then it's talking about horizontal asymptote. Yeah, we got a horizontal asymptote right there clearly. That's at, looks like 3. I'm sorry, negative 3. That's negative 3, going down. Okay, now what's the domain here? All right, on the domain now, I'm going to write the domain right here. On my domain, I've got 2 vertical asymptotes, so both of those have to be taken out of the domain because it's a value x cannot be. So my domain is going to go negative infinity up to this first value of negative 4, and then I'm going to close it off before negative 4. Then I'm going to pick up on the other side of negative 4, and I'm going to continue on to positive 4, and I'm going to cut it off. And I'm going to go from positive 4 to positive infinity. And so essentially, I'm taking out negative 4 right here because x cannot equal negative 4, and I'm taking out positive 4 there. These are my 2 asymptotes, and my values of x cannot be. So there you go. There's my domain. Okay, and you can see the answer right down here. See, that's what we have. All right. And we just got a few more here. Now, graph this one. Graph this function. All right, so what you're going to focus on is your vertical asymptote and your horizontal asymptote. My vertical asymptote down here, what can x not be? Well, negative 3. My horizontal asymptote, all right, my degree in the numerator is that's 1. My degree in the denominator, well, that's 1. And look at our notes here, they're equal, which means I divide those lead terms. So I'm going to divide, this is a 1 here and a 1 there. 1 divided by 1 is 1. So that's y equals 1. Okay, so I look for the graph that has these 2 asymptotes. All right, so it's going to be negative 3 for x right here. This looks like negative 3. And then y equals 1. Well, this looks like it's negative 1 here. That's not right. This is positive 3. That's wrong. All right, here's negative 3 again, and this looks like 1. This looks like it might be it right here. Let's look at the last one here. Yeah, this is positive 3. It's C. Okay. Here's another one, number 11. Same thing. Graph a rational function. All right, so you look at your vertical asymptote and your horizontal asymptote. My vertical down here, clearly, x cannot equal negative 1, but that's my vertical asymptote. X equals negative 1. All right, so let's look at those. X equals negative 1. All right, this looks like x equals positive 1. All right, here's negative 1 right there. So it could be that one. Here's negative 1. Could be that one. This is positive 1. That was not it. So just based on the vertical asymptote, it's B or C. Now, what's my horizontal asymptote? All right, well, look at the degrees. My degree in the top is 1. My degree in the bottom is 1. Okay, so my degrees are equal. All right, so my denominator equals the numerator, which means I'm going to divide the lead terms. So when I divide, this is a 1, that's a 1. 1 divided by 1 would be 1. Okay, so it's y equals positive 1, which, see this one here, this looks like negative 1. This is it right here. See, y equals positive 1 right there. So let's see. Okay, and one last problem, number 12. Okay, let's sketch and graph this. All right, so we're going to look at the vertical asymptote, horizontal asymptote. Okay, my vertical right here in the bottom, 9 minus 9 would be 0. X equals 9. That's my vertical asymptote. So if I look here, this looks like 9, this looks like 9, this looks like negative 9, that looks like negative 9. Okay, so it's got to be A or B based on the vertical asymptote. Okay, now what about my horizontal asymptote? All right, well, if you look here, my degree in the numerator right there is 1. My degree in the denominator, it's 1. All right, so looking at my notes here, they're equal, so I divide those lead terms. So I've got a -2 divided by a -1. -2 divided by -1 is +2. So y equals +2 is my horizontal asymptote, which looks like this one here. So yep, this is -2. It's got to be B. Okay. And I think that's it. So wish you luck on this assignment. If you have any questions, need any help, just contact me anytime. Y'all have a good rest of the day.